Hey everyone, in this video I want to talk about the App Service Environment v3, this brand new version that actually solves a lot of the problems we had in the past. As always, if this is useful, a like, subscribe, comment and share really is appreciated, and hit that bell icon. Now, for the most part, the inner workings of an app service plan or app service environment, we don't care about. It's a black box. But when we think about, well, what are the differences, it can be useful to understand what are some of those core architectural components. Now, in the beginning, almost at the start of Azure, was the app service plan. Azure really started as PaaS. So I can think about, well, when I create an app service plan, there are various resources actually at play. Now, it's a multi-tenant environment, i.e. there are multiple app service plans running on a certain app service scale unit. So you can think about, well, there's a whole bunch of infrastructure that powers this app service plan. Now, in terms of what some of those components are, I can think about, well, there's kind of file services components. There are publisher components, for example, for FTP access. I can think about, well, there are various types of front end to actually at layer 7 accept those incoming HTTP and HTTPS requests. There are various types of data role in here for caching when it goes and talks to kind of the Azure SQL database. There's load balancers. There's all these various components. There's virtual IPs for both inbound and outbound communications. And then what happens is, so that's all part of the scale unit where my app service plan lands. So I can think about these bits here. Well, these are all shared. Now, when I create an app service plan, what also then gets deployed is, let's say I go and create an app service plan, and I just call it Plan 1. So what happens is also there are various workers deployed. Now, that's actually doing the bulk of the actual execution and running of my application, be it a web app, a mobile app, an API app, maybe functions. Windows and Linux all supported on this. So my app service plan actually has some dedicated workers, unless I'm using the free or the shared, and then it's using up a certain slice, a certain portion of the capacity of those various shared components. If someone else comes along and creates a plan, well, they've got some dedicated workers as well, and they too take up a certain slice of the capacity of that shared set of infrastructure. Now, they're all isolated from one another. That's kind of a key tenet of this, but those parts are shared. Then I have my dedicated workers. Now, for these workers, I can actually scale up to 30 within my app service plan. And then with that app service plan, if I can think about this is the plan, I can then deploy one or more applications into that plan. If I have things like deployment slots within an application are still taking up that shared set of infrastructure. It's not creating different boxes for different deployment slots. It's using those same set of workers, that same portion of the space. So we have these capabilities, we have these shared things, and that all seems great. Now imagine, okay, that's my app service plan. I have a virtual network. So I have a virtual network. That VNet may be connected to other networks, maybe on premises with ExpressRoute or site-side VPN. It could be peered to other networks, whatever that might be. Well, maybe I need things running in my app service plan to be able to communicate to resources that sit in that VNet or are connected to it. Well, how do we do that? This can't deploy into my virtual network because of all these shared pieces. And there's other bits as well, like Azure SQL Database, Azure Storage, there's all these other bits. So I can't just connect it to my VNet, put it in the VNet. So instead, if I need to get to something in my VNet, there are various solutions. Now, I did a deep dive video on this. I'll kind of link it up here about how PaaS can integrate with my virtual network. But one of the options, there's kind of this regional VNet integration. So I have a certain subnet, and basically the app service plan integrates in there. So I have this regional VNet integration. So now it can talk to things. All of those apps within that plan can talk to things in that VNet or are connected. But I need a whole dedicated subnet per app service plan. Then if I want private connection to the application, well, then I use something like a private endpoint. So private endpoint 1 goes to that application. I'd need another private endpoint to go to that application. As you can see, after a while, it starts to, from a scale perspective, not be particularly great. If I had lots of app service plans, well, I'd have to have lots of those separate dedicated subnets per plan, lots of apps, lots of those private endpoints. And sometimes I just don't want to share any components. Sometimes I want to go more than 30 workers. So there are just these certain limits. There's certain pain points of integration. There's certain aspects of I don't like sharing. I was an only child, don't want to share. Maybe scale. And so because of all of those things, all of those various reasons, that is why we have the app service environment. And I am going to focus on, I'm going to use the glittery universe, the V3. Like a fanfare, we're going to talk about the V3 option. Now, one of the big deals about this is when it deploys, it actually deploys into your virtual network. So here I can think about, well, once again, I have the idea that I have my VNet. So I've got my virtual network. And once again, within here now, I'm going to create a subnet that I'm going to dedicate for this particular ASE. I'm going to create this ASE VNet. I then deploy my ASE actually into that virtual network. So that's my VNet. I've created a subnet, and I'm now actually going to deploy my ASE into there. So now it can very easily integrate with other things. Now the way this works is I can think about, I am going to go ahead and create my ASE. So I can think about, okay, my ASE is going to live in here. And we're going to talk about some of the components in a second. But within there, this is my app service environment. So I've created an app service environment. Within the app service environment, I then deploy app service plans. So the same way I would normally create an app service plan where I would specify a region I want to create the app service plan in, this time I would specify the app service environment as the target for the plan. So here, okay, within the app service environment, I could now create an app service plan. I could create multiple app service plans. So I'll create a second app service in plan. And then within there, I would, as usual, go ahead and create applications. App 1, App 2, I could create App 3, etc. So it's app service environment. Into that, I create app service plans. Into those, I deploy applications. So that's how those things actually function. Now, in terms of, well, what do I do? What are the components I specify actually as part of that app service environment? Well, I can think about what I really focus on here are the actual workers. So there's still various shared components, but I'm going to focus just on the workers. The other parts are just going to get taken care for me. So we focus on the workers. And what we're going to use is there's a special SKU. So there's this isolated V2 is the SKU. Now they come in various sizes. I could also deploy them if I wanted to on dedicated host, i.e. host groups. That's where in this case I could specify kind of 2 hosts that are dedicated, i.e. only my VMs get created on them, and that's where the ASE various components would actually get deployed. So boxes, physical boxes dedicated just for me. That's completely optional, but I can absolutely do that. Now, in terms of the scale, I mean, always think about the instances of these isolated V2 SKUs I'm going to put into this ASE V3. I can have up to 200 instances. Now, those 200 instances can actually be spread across 200 app service plans. Now, it's 200 in total. So I could have 200 app service plans with one instance each. A single app service plan, so I can have 100 in one app service plan. And I can really divide that up however I want. I could have one app service plan with 100 instances, and then 100 other app service plans with one instance each. 200 total instances, a single app service plan, up to 100 instances. So that's how I can think about really balancing those various components. So that's what's actually going to power it. Now, obviously, if I use dedicated host, that's just 2 boxes. I'm not going to be able to reach 200 instances. Yes, I can fill up that dedicated host with the individual isolated V2 VMs, but I'm not going to hit 200. The boxes are not that big. So I would limit my scale if I use the dedicated host option. But straight away you can see just from a scale perspective, regular app service plan, hey, I could go up to 30 instances in a plan. In an app service environment, I can go up to 100 instances in one plan. It's deployed into my virtual network. So now if there were other resources, there's no VNet integration. There's no private endpoint. It lives in the virtual network. There's really nothing else I need to do. It's just there. I've deployed it. These things can all interact. Now, in terms of pricing, there has been a big change with the V3. Now, obviously, what do I pay for? So the big thing is there is no stamp fee. So I used to actually have to pay to have an app service environment and then pay for the various workers. I don't pay for that anymore. There is no stamp fee. What I pay for are these. And they kind of bake in the price as I have to have those other components to actually support it. Now, if I do the dedicated hosts, then I pay for the 2 hosts, and then I pay an additional kind of 20% of the regular isolated V2 core fee. So I pay a bit extra as it actually deploys those cores. It does support reserved instances. So if I know I'm going to use these things for a prolonged period of time, I can get that benefit of actually committing to a 1 year or kind of 3 years. If I create an app service environment and it's empty, I don't create any app service plans. So if it's empty, but only if it's empty, there is a charge for one isolated V2, and it's the I1 V2. So it's actually, let's change that. So it's the smallest SKU. So you do get billed for the I1 V2. That's only while it's empty. That's not an ongoing charge. As soon as you actually put app service plans into it with regular IV2 SKUs for the actual instances, that charge goes away. It's just if it's empty, hey, they have to charge something. You can also deploy as an ASE resilient, so it spreads it across the 3 availability zones. Now, because I'm distributing over 3 availability zones, a lot of the supporting stuff that it actually has to do has to be deployed in a resilient way as well. So if I do an ASE v3, from a billing perspective, the minimum is 9 I1 V2s. And we're always going to really have multiples of 3 because we've got 3 availability zones. Now again, that's just the minimum. As soon as I've added 9 IV2 SKUs, this is not an additional charge. It's just it has to bill you that as a minimum to take care of all the other components. It actually has to be running to actually make this thing work. So from a billing perspective, realize, hey, if I choose to do an AZ resilient ACE V3, well, at minimum, I'm getting charged for 9 of the I1 V2s to cover all the various costs that have to go into supporting all the various other pieces of infrastructure. And I'm actually going to talk about that. So those are my options. Hey, generally, I'm just paying for the isolated V2 SKUs. I can optionally use dedicated host on 2 physical boxes. I can do AZ resilient, but then there's kind of a minimum number of instances I have to pay for to cover all the zone resilient other components that actually have to be deployed. Now let's double click a little bit into kind of the networking side. Now I said it deploys into its own subnet. The recommended size for that is a /24. That really takes care of support. Remember, I can have up to 200 instances, so that would be kind of 200 IPs. But remember, there are other components as well that kind of auto deploy out as required based on the number of instances there are. So other IP addresses will get sucked up for those other kind of supporting components. There are kind of some IP addresses for load balancers and other stuff as well. Which brings me to the next point. When I deploy an ACE v3, or even the older versions, I pick, is it externally facing or internally facing? And that really just boils down to the load balancer that kind of fronts this, is it internal or external? So it's either going to have an internal virtual IP, i.e. it's internally facing, or it's going to kind of have an external virtual IP, i.e. a public IP. So it's either going to be an internal load balancer or an external load balancer into which that HTTP, that HTTPS traffic is going to flow in and actually get to my app service plans within the ACE. This by far is the most common. Make it internally facing. Now you may wonder, why is that? Why is that the most common? Think about a lot of the best practice architectures. If possible, especially for kind of these layer 7 intelligent applications, I can think about, sure, I have my kind of load balancer, and I can make that internal. So it's kind of this internal virtual IP. If I want to make it externally visible, well, a really good pattern is I use something like App Gateway. So I use App Gateway to front that. Then I can have things like a web application firewall to help protect me from those common types of attack. And this has the external VIP. It receives the traffic. It does the checks. It has all the rules, then sends it to the internal, which can then send it to those kind of actual back-end applications. So that's really the most common pattern. Even if I intend to make it publicly available, make it an internal ACE and publish it with kind of the app gateway. Then I also have a nice benefit of, hey, I can use it internally very simply as well. It's a very nice pattern to have. There are some edge scenarios where maybe I just do external. Maybe I just need a massive availability. It's not going to run for very long. Sure, I could just do the external VIP. But most of the time, you're going to use an internal VIP and then publish it with something else. So that is kind of the key scenario. Now, this is the V3. There were previous versions. One of the pain points in the past was the fact that the ACE deployed into your virtual network. Now, if you think about what the ACE actually needs to run, well, it has to be able to talk to the Azure Resource Manager, has to be able to talk to Azure AD, has to be able to talk to Azure DNS, has to be able to talk to Azure SQL, Azure Storage. There's a whole list of things it has to be able to talk to. So what would happen in the ACE v2, Well, it's all sitting in your subnet, in addition to all its other supporting services. So what could happen is people would essentially apply NSGs or user-defined routes or firewalls or NVAs or other things that would block communication. And when you block the communication, it would break because it can't work anymore. It's no longer able to function. So that was the ASE v2. The ASE v3 doesn't care. You can pretty much do whatever you want. It's not going to break it. The only thing is basically health probes from the load balancer have to be able to work, obviously, and I have to be able to receive the inbound traffic. I am sending in HTTP, HTTPS, it has to be able to get to it. If I block at the subnet HTTP and HTTPS, it's not going to work. If I block health probes from the load balancer, it can't check their health feed. But that's the only thing now. I can mess up pretty much anything else. The ASE is still going to work. Now, how does this work? And again, I kind of talked about, it is a black box. I do not need to know these things. But just to help us understand how is this possible, you can really think about, okay, what's really happening underneath is we have this ASE v3. And it actually comprises of a bunch of different things. We can think about, well, there are still kind of file servers. We still have those components. We still have those layer 7 kind of front ends to actually come and receive the traffic. And these are a separate component. Then there are kind of these multi-role things that combine a lot of the separate things in a regular app service scale unit when it's multi-tenant. Then, of course, we have the workers. So there are these various bits that actually make up the ASE and allow it to function. Now we think about, well, we deploy this into our virtual network. So I can think, hey, there's my VNet. And really what it's using the VNet for primarily is, hey, yeah, the workers can kind of come in and talk to things in the VNet. I have the load balancer. Now remember, that could be internal or external. For the actual regular traffic, actually that's going to then come in and go to kind of the front ends to then get processed by the various roles. We're used to that idea. But then what actually happens is there's really this idea of magic. So we'll draw it as magic. But it's not really magic. Fundamentally, you can almost think about, well, there's this separate infra VNet that we do not see. That's not in our subscription. That's completely separate. You can almost think about these things can kind of be multi-nicked across different virtual networks. That's not something we can normally do in Azure. And it's not really the way it's working, but there's some special plumbing that what it enables it to do to these roles, they actually can all connect to this kind of infra network and talk to each other through this infrastructure virtual network. And through that, it goes and talks to all of those other services we talked about up there. So the things it needs to function is not doing through the customer VNet. The things it needs to function, it has its own virtual network that it manages that we can't see and that we can't impact to make sure it can still get to and operate as it needs to. So that's really the key point on how the ASE removed the pain points that people would break the communication. Again, we don't worry about this. It's a black box. But just so you understand what it's doing, so you understand why it doesn't matter anymore, your VNet is really used for kind of that inbound, outbound communication with the clients of the service. Its inner workings, the plumbing that it needs to actually function, it's separated out into its own infrastructure so you can't break it, so you don't have to worry about it. It's just going to work for us. So that's really kind of the key point of everything gets done. So that was kind of what the ASE is. I kind of want to just explain that so you could understand the differences between it. But it is a black box. This is not stuff we have to worry about. What you think about is, hey, it deploys into a subnet. I just need to make sure I can get health probes from the Azure Load Balancer and I can receive the traffic, HTTP, HTTPS, coming in to process it. I size it accordingly. If you can just do a /24, it will kind of cover those maximum scales. I just pay for the isolated V2 SKUs now. I can create multiple app service plans in it, but I get this massive scale. I get this phenomenal integration now with my virtual network. It's part of the VNet. I no longer have to worry about, okay, per plan, do a regional VNet integration, which needs its own subnet, and then per app, it needs its own private endpoint, and oh my God, I've got 10 app service plans and 50 apps. Well, okay, so that's 10 dedicated subnets and 50 private endpoints. Don't have any of those worries. So I get this fantastic ability to operate. I'm not sharing anything. I get great scale, and that's the point. And with the new pricing, the fact that I'm not paying stamp fees anymore, I'm really just paying for the capacity I'm actually using. It may not even cost you any more, really, in the long term than a regular app service plan. So this may actually be a very attractive thing to go and look at. Whereas before, maybe the stamp fee was maybe a blocker and it made it seem worse than it is. Maybe the concerns before about, oh, okay, I can break the networking. It really is a black box. I don't have to worry about these things. It's very hard for me to actually break this thing now, but it just gives me all those great benefits. The VNet integration, the massive scale capabilities, and I'm not sharing anything. So as always, I hope that was useful. Again, a lot of work goes into preparing for these, so a like, subscribe really is appreciated. But until next time, ace it.